Hi, this is Craig Uranic, and today we're going to study function notation. To understand it, we're going to break this up into two words, the word function and the word notation. Notation is simply a different way of representing a quantity or a value. So the way that we're going to re-represent equations is going to be like this. Now, from your past experience, you understand that the way we wrote this before was with y equals. So again, we're just talking about different notation. The second word is function, so let's talk about what we already know about functions. Graphically, functions are a set of ordered pairs, and when you plot them on a grid, they give you a curve. We also found that because the definition of a function is that for each input you get just one output, because of that fact, we found out that the vertical line test holds true. The vertical line test simply says if I go across a graph of a function vertically with vertical lines, that I should only get one y value whenever I pass through there, which we do here. That's what a function is from a graphical standpoint. Now, from an equation standpoint, we found that functions can always be written in y equals form. The reason being because of the very definition of a function, which is that for any value that I input, I get a unique y value or a unique output value back. So there's your background on functions. So function notation is nothing more than writing an equation in y equals form, but instead of using y, we use f of x. The way you say it is f of x. It does not mean f times x. It simply is replacing y. In other words, y and f of x are the same thing. They are equal. Let's say we wanted to evaluate this function when x equals 4. So, we would first substitute the x equals 4 into the equation. Let's first use this equation here, this form of the equation. So y equals 2x. Instead of x, we're going to substitute the 4 in for it. Substitute is like in sports when you substitute a player in for another player, they go in for or replace them. So that's what's happening in substitution. It's replacing the x. We end up with y equals 9. 2 times 4 plus 1 is 9. Now, that's perfectly fine. We've just evaluated that when x equals 4, y equals 9. Now with the function notation, we actually write it a little bit differently, but we get the same results. We can say, instead of f of x, I can literally put the 4 in there, meaning that in the equation of 2x plus 1, wherever there's an x, I'm going to put a 4. So I'm going to do that substitution. So, f of 4, when I plug 4 in for x, will equal 2 times 4 plus 1. The results are the same. F of 4 is equal to 9. Now notice this tells me a little bit more information. It tells me that I plugged 4 in and got the value 9 as output. So this is the input, this is the output. When I just used y equals, my answer was right here. Y equals 9. That does not tell me as much information. I would have to write in an ordered pair to tell me more information. Plug in the input of 4, we get the output of 9. Notice this form, in function notation form, that I know immediately that my input value was a 4 and my output value is a 9. So really the only difference with function notation is it gives you more information about what's going on. Choose which video you would like to review, either the function notation or one of the examples from the section.